PreCalc, hello. This is the After Thursday class edition, so that's November the 3rd. So let's look at our review materials to help us with the test. The take-home test is due tomorrow. Just remember what kind of tools. So you carry your toolbox around. Remember that big vertical toolbox, and one of the tools is change everything to sine and cosine. So that's one tool, and you do that often with these functions, these IDs. Cosine over sine is the cotangent, and the sine over the cosine is the tangent. Those are often the ones you'll use to do that. So change everything to sine and cosine. It's not very clear. Clarify my writing. Alright, so then the second tool in the toolbox is factoring. So, when we factor, let's look at what happens with factoring. One of the tools of factoring that you may have forgotten, but it is a missing thing, is the difference of two squares. So anything that is squared minus something else is squared can be factored. And it factors like this: a minus b times a plus b. So this will pop up in the middle of our simplify, verify trig problems. And it'll look something like this. Something that's squared, that was 2 squared, minus something else that was squared. So cosine was squared to get cosine squared. So that can factor. You have to know what your a is and what your b is. So your a is 2 and your b is cosine. So plugging that in, we get 2 minus cosine x, 2 plus cosine x. So sometimes right in the middle of a trig verify or a trig simplify question, you will have to factor. And this is one way of factoring. Another way is to remove common terms. So if you had sine x cosine x plus cosine x. Let's say we have sine squared x. Let's just change that a little. So suppose we're asked to deal with an expression like this. The kind of factoring you'll need with that is the pullout was common to these two terms. So what does this term? Remember, terms are connected by addition. Inside of a term, the connecting glue is multiply and divide. But in between terms, the connecting glue is minus and plus. So here we have one term, two terms, and the plus or minus divide the terms. So in the first term, this has a cosine, and the second term also a cosine, so I'm going to factor it out. When I factor it out, I have to put, and behind it in parentheses, I put what will multiply times the cosine x to get me back to this first term. So what's left when I divide out or factor out a cosine x? And when the whole term is removed, it's replaced with a 1. So this is a trig ID, sine squared minus 1. And let me go over then the third tool, and that is substitution. And when we use substitution, we're going to put in trig IDs for other trig IDs. So sine squared minus 1, you'll recall, is one of the Pythagorean, one of the Meritorial Service Award winners. And that's sine squared plus cosine squared equals 1. In some of your work, I see this kind of error come up. Sine plus cosine equals 1. No, 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 no. All right, so it has to be squared for it to equal 1. So be careful, don't make that assumption. It is erroneous. Remember that this has two other forms. I saw on some of your trig ID pages, I asked you to put the other forms in. They were not there on some of our pages. So remember, we can rearrange that. And so we could say, we can move the sine squared to the other side of the equation where it becomes negative. Leaving the cosine on the left. So that's another form of the same one. And we can isolate sine squared by moving cosine to the other side by subtraction. So these are all three forms of the same trig ID. So looking over here, I see cosine x equal times sine squared minus 1. Let's see if that's one of our trig IDs. So sine squared minus 1 is almost right here. So if you look up your sleeve, you'll see a way to make this look like this. So I can use cosine squared. And the trick was we pulled out a negative. So when I pull out a negative or divide out a negative in front of that, it's as if I pull out a -1 in front of the parentheses. And that will cause everything in there to change signs. So the positive will become a negative, and the negative will become a positive. I'm going to put this -1 in front of the cosine to clean it up a bit, and I usually write it in this order. Now this is the same as this trig ID here, this version. So I can substitute, and that's where I was using the tool in my box, substitute. So I'm going to replace 1 minus sine squared with cosine squared by, hold on to your seat, by substitution. Then I'll call this cosine squared. And together that's the minus cosine cubed. So that's just an example of factoring and substitution. All right. There are two other Pythagorean IDs besides this, which have two other forms each. They should all be in your composition book in your memory page and in the body of your composition book. So let's see what the last tool is in our box. Add. You're going to need to add algebraically in some of these trig ID problems. And for example, when you're going from 2 terms to 1 term, so let me see if I can find one. Where is one that I had planned to show you? Let's just take this one. We'll take cosecant x minus cosine x. Again, that's 2 terms. Terms are divided by plus or minus signs. So we have 2 terms. And say we're going to simplify it. And when we do that, usually you have to add. I don't have a real good example. I just kind of pulled that out of my head. But let me show you how to add so that it's no longer 2 terms, it's 1. So first of all, I'm going to change it to sine and cosine. So cosecant is the flip of sine. So I can write cosecant as 1 over sine. And this has the denominator of 1. So I want to give this the same denominator so I can combine them. And when I do that, I'm going to multiply this by cosine x over cosine x. And that causes 1 minus, I'm sorry, not cosine. let me go ahead and change that to, let me change this to sine, because then everything, like I said, I was making this up, so I'm making up another one. Let's see, I want to combine these, so I'm going to multiply this by sine x over sine x. Because this has a denominator of sine x, I'm creating the denominator of sine x by multiplying this term only by 1. And that will give us 1 over sine x minus, these two signs combine, sine squared x over sine x. So now I've created the common denominator sine x. I get 1 minus sine squared x over the common denominator sine x. And 1 minus sine squared is cosine squared. So I get cosine squared over sine x. We're not done until all the division, the fraction lines division. This is cosine squared x divided by sine x, that divided by line. The fraction line should be eliminated to be in simplest form. So what I've seen done is take the cosine and split it up. I remember helping some of you do that. And now this is a trig ID. It's tangent, cotangent. And so how many terms do we have now left? I got to use x or not. So, all right, how many terms do we have now? This is one term because it does not have a plus or a minus sign in it. All right, so I was just showing you how to add algebraically by creating the same denominator, and this one happened to pan out in that way. I think number 18 has some issues in that you might not know where to start on number 18, the last one. So I'll give you a clue. We are going to take that first term in number 18, the term on the left, and multiply it by cosine over cosine. So that's just another form of 1, so you're allowed to multiply anything by it. So multiply the first term in number 18 by cosine theta over cosine theta, and see if that doesn't get you to the other side with some other manipulation. But all the things, all the clues that I've set in front of you probably will come out to play in number 18. But I'll give you the first step. But that's all. All right. Once again, those are some clues to help you with the simplify and verify problems on your test. So I hope that you can finish it up. Good time tonight. Don't work too late when you're too tired. Give yourself the benefit by working when you're most alert. All right, that's it for tonight, and I will see you in the morning. Till then, goodbye.